Hi everyone. In this video, we're going to talk about another form for the equation of a line that's called the point-slope form of a line. So we call this point-slope form of a line because the information that I need to figure out the equation is the slope of the line and then any point will do. So when we have the slope-intercept form, what we get is we get the information about the slope and we get a particular point, which is the y-intercept. And in this equation, we can just use any point. Now, this is often an advantage to us because if we're not particularly interested in the y-intercept, then we don't need to do the additional work of the algebra to figure out what the y-intercept is. And this is often a faster way for us to figure out the equation of the line. So the first thing I want to do is give us a little bit of perspective and maybe a way to understand why this is the form of a line and why and where it comes from. So in our last videos, what we had was we talked about slope a lot, and we saw that slope was the change in output over the change in input, and we used this formula for slope. We said y2 minus y1 over x2 minus x1 is equal to m. So that would be our slope. And so one thing that I want to point out here is there seems to be a lot of similarities between this slope equation, right? So this equation right here and the point slope form of a line. So I have the difference in y coordinates, so I have a y minus y1, and I have that also over here, except I have a y2 minus y1. And then I have a difference in x's, which I also have down here, and then I have an m in both of them. So what I'm going to do is multiply both sides of this equation by my denominator to bring it over to the other side. So over here I'm going to multiply by x2 minus x1 on the left. I'm going to multiply by x2 minus x1 on the right. And what we're going to see is on the left-hand side, these things cancel. So if we think about that, really what I have is this x2 minus x1 is acting as its own unit. So this multiplying by x2 minus x1 and dividing by x2 minus x1 are going to cancel out. And what I have left over is, well, y2 minus y1 equals m times x2 minus x1. Now, if I'm dealing with the equation of a line, what I need is I need an input and an output. I need something to represent my variable. And what I have in my equation right now is I have 2 points. I have an x2 and a y2 and an x1 and a y2 that are very particular, but really we know that they could be anything. And so if I just go ahead and let's just get rid of these subscripts, this y2, and let's get rid of this x2, because I don't need to have them be a particular point. I can really have them be just any point that I want that satisfies this input-output relationship. And then when I make that change, what I see finally is that is the point-slope form of my line. So if I remember what the slope is, change in output over change in input, that gives me a very quick way to remember what the point-slope form of a line is and where it comes from. So the next thing that we're going to do is we're going to see if we're given some information, how do we find the equation of the line? So I'm going to pause the video for a second and come back with an example. And we're back. So we have this question in front of us. Find an equation of the line with slope -6 passing through the point 4, 8. So with this information, what I have in front of me is I have the slope and I have a point. The point that I have is not my y-intercept. It is just another point. So I could use my slope-intercept form y equals mx plus b and then solve for b. But what we're going to see here is if I use the point-slope form, my life is a lot easier. So before I write it down, think to yourself, right, what was that formula? What is the formula for the point slope formula line? So you can think about it. Pause the video if you have to. And what we get is the form is this: y minus y1 is equal to m times x minus x1. Okay. Now there's a lot of stuff going on here, so let's go ahead and talk about it and see what information we can get from our question. So the first thing that we have is we have inputs and outputs. So this y, this is our output. Okay, so this is our output here, and this x, this is our input. Okay, so we have our input and we have our output. Then we have m is our slope, and x1, y1 represent our point, right? So this is the y coordinate of our given point, and this is the x coordinate of our given point. So when I go above, the information that I'm looking for is what's my point, and so I have that here in green, and then I also look for what's my slope, and I have this here in red. So if I put all of this information together, what I'm going to get is that my output y minus that y coordinate, so I come over here and I look, I say, all right, here's the y coordinate of my point, so that's 8. So we're going to put that in here. 8 is equal to my slope, which is -6, times my input, which is this x, minus, well, then I come over here and look for that x coordinate of my given point, which is 4. And so if I want to leave it like this, so let's make this the right color. So if I want to leave my equation like this, that's totally fine. I can leave it like this. I can say y minus 8 equals -6 x minus 4, and we're totally good. Oftentimes, especially on web work, they're going to ask you for something that's y equals. So you'll get something like this: y equals -6 x minus 4, and instead of having -8 on one side, all I'm going to do is I'm going to add it over to the other side, and I can write it like this. So these are both acceptable forms. It just depends on context what you're looking for. All right, so if I have the slope and I have any point, this is a very quick way to figure out what the equation of my line is. So I'm going to pause the video again one more time, and we'll come back with one more example and see if we can use this just given 2 points. All right, we're back with our final example. Find an equation of the line passing through the points -1, 4 and 8, 11. So this would be your opportunity. If you want to pause the video and try to work this out before I do, you can do that now. Okay, so what I have in front of me is I have 2 points, and the other piece of information that I need to find the equation of the line is the slope. So the first thing I want to do is I need my slope, and then the second thing I'm going to do is use one of my points. So these are the 2 things that I need to find the equation of a line, and lucky for me, I already have this. I already have a point, so this one, good to go. What I need is just my slope, and then I can use our point slope form. All right, so if we go back, we've talked a lot about slope, change in output over change in input. So my slope is given by this: y2 minus y1, all divided by x2 minus x1, where these are the coordinates of my 2 points. All right, so what we'll do is we will have one of our points. We'll call point 1 just the first one here, right? So this will be our first one, and this one over here, this will be my second point, just so I know which one I chose and which order to put them in. So y2, the coordinate over here is 11, and y1 is 4. So I got 11 minus 4 divided by my x2 coordinate is 8 minus my x1 coordinate is negative 1. So I'm going to put this in parentheses like this, 8 minus negative 1. And 11 minus 4 is 7. 8 take away negative 1, that's the same thing as adding 1, so I get 7 over 9. So when I have a fraction like this, I have 7/9 is my slope. If I was going to go ahead and try to use the slope-intercept form, I'm going to run into some really messy algebra. So this in particular is a nice case where using the point-slope form is going to be an advantage to me. Well, I already have a tip to tell me what the point-slope form is. So I have this over here. I already have my slope, and I know if I just bring this x2 minus x1 over to the other side, that gives me a very good hint at what my formula is. So if we recall, the actual formula is y minus y1 equals m times x minus x1. All right. So what do we need? The first thing we need is I need my slope, which I have over here. And then I need a point. I need x1, y1, which I have up here. So let's go ahead and just plug our information in, and we will be good to go. So y minus my y1 was 4 is equal to my slope, 7 over 9, times x minus my x1, that was negative 1, x minus negative 1. And so if we put all this together, what we get is we get that y is equal to 7 over 9, that's my slope. Taking away a negative 1 is the same as positive 1, and then I'm going to add my 4 to the other side. So if I want to write this with just y on one side, I could say the equation of my line is y equals 7/9 times x plus 1 plus 4. So I hope this helps, and I hope you use this equation for a line. It's my preferred method, and I think it will save you a lot of time. All right, see you next time.